In the first video of mathematical induction, we saw Gauss summing up all the numbers up to 100, the natural numbers, and he derived the formula n plus 1 by 2. That was not mathematical induction. Mathematical induction essentially requires us to prove certain statements. In this case, we are trying to prove that S, which is the sum of n numbers, is n plus 1 by 2. So we are given a statement and we have to prove it. It's a method of proof. What we do is first we look at value 1. So whatever the value of that statement is it true for value 1? Is it true? Yes. Is it true for any other number k? It is true. And we have to then show if sk is true for number k, then sk plus 1 is also true. If this happens, we've shown the proof. So this is essentially the algorithm which we use. Show that the first number holds true for the question, then any generic number holds true, and then sk plus 1, which is the generic number plus 1, holds true. If we notice what happens, the first step, which was S1, S2, sk plus 1, and you keep going. The first step, which was S1, this is called the basis step. The second step onwards, we reach the generic step, which is what we call the inductive step. Okay. We prove here sk implies sk plus 1. So this is what matters. This requires some little form of manipulation. Now we'll look at Gauss's series and we'll prove that by mathematical induction. So the series was S is equal to 1 plus 2 plus ... till n. S was n plus 1 by 2. Okay. So what we do, is it true for 1? 1 plus 1 by 2. What is this? This is 1. So the series is 1 plus 2 plus 3 plus, let's go till 100. It's true for 1. It's true for 1. Now let's see. Sk is equal to k plus 1 by 2. What is sk plus 1? You have to show that this implies sk plus 1. Sk plus 1 will be k plus 1. Here we substitute k plus 1, and then in this k we substitute k plus 1 by 2. This is what it should hold, right? This is what we have to prove. We have to prove this. So let's look at this. Now we say sk plus 1 could also be written as sk plus k plus 1, isn't it? Because suppose this was number 7, then the next number we add is 8, k plus 1. But we know from this sk is k into k plus 1 by 2. So k plus 1 by 2 plus k plus 1. Now it's just a manipulation exercise. We can take k plus 1 out common. We have k by 2 plus 1. What is this? We have k plus 1, k plus 2 by 2. This 2, let's just break it up. So we have k plus 1, k plus 1 plus 1 by 2. And this is exactly the same. So sk plus 1 is proved to be of the form n plus 1 by 2. Hence proved. This is a fairly simple method of proving. We can look at other questions. For instance, in this book, by George Andrews on number theory. Actually, the first chapter itself is on mathematical induction, principle of mathematical induction. And if you look at some of the questions which he is given, let's look at the questions. Yeah. We have another question, which is the square of the natural numbers 1 square plus 2 square plus 3 square plus n square is n plus 1, 2n plus 1, 6. You can do this. This is also fairly simple. So let's look at this question. So we have 1 square plus 2 square dot to n square. So s is given by this, and the hypothesis here, what we have to prove here, is n plus 1, 2n plus 1 by 6. So let's look at s1. Is it true? Let's put it 1 plus 1, 2 into 1 plus 1 by 6, 1 into 2 into 3 by 6. This is 1. So s1 is true. Now let's look at sk. Let's put sk. So we have k plus 1, 2k plus 1 by 6. Now, what will sk plus 1 be? It will be sk plus k plus 1 whole square. So suppose this was 6 square. So it was 6 square. The next number will be 7 square. So this was 1 up to 6 square, and then we have 7 square. But we know sk is k plus 1, 2k plus 1 by 6 plus k plus 1 whole square. Now this looks like a long expression. To prove this, let's take a slightly tangential route. If sk plus 1 was true, we would actually get the equation as, let's look at, we're going to modify this. We'll get it as, we'll substitute k plus 1 for n. So we'll get k plus 1, we'll have k plus 1 plus 1 as the second term. Then we'll have 2k plus 1 plus 1 by 6. This is what we have to get at. This can be simplified as k plus 1 by 6. Okay? So we have k plus 2 into 2k plus 3. This is what you have to simplify as. Let's make it even simpler. K plus 1 by 6. This is 2k square, 3k into 4k plus 4k, that's 7k, and in 2 into 3 is 6. So this is what sk plus 1 should equal in this expression when you manipulate it. And then we will be able to prove that this equation holds true. So we can easily simplify this. K plus 1 outside, that's 6. So we have k into 2k plus 1 plus 6 into k plus 1. Let's simplify this expression. K plus 1 by 6. We have 2k square plus k plus 6k plus 6. We can see that we are reaching the same expression as that. We have k plus 1 by 6. We have 2k square plus 7k plus 6. This is exactly as this one. So we are able to prove this expression, right? So this is how mathematical induction works. Let's look at maybe one more problem related to modulus functions, or rather I can introduce this in the next video, modulus and congruences, and we'll start with one proof using modulus and congruences. So that is the first introduction to mathematical induction.